Compression in HTTP. Compression is an important way to increase the performance of a website. For some documents, size reduction of up to 70% lowers the bandwidth capacity needs. Over the years, algorithms have also got more efficient, and new ones are supported by clients and servers. In practice, while developers don't need to implement compression mechanisms, both browsers and servers have it implemented already, but they have to be sure that the server is configured adequately. Compression happens at three different levels. First, some file formats are compressed with specific optimized methods. Then, general compression can happen at the HTTP level. The resource is transmitted or compressed from end to end. And finally, compression can be defined as the connection level between two nodes of an HTTP connection. File format compression. Each data type has some redundancy, that is, wasted space in it. If text can typically have as much as 60% redundancy, this rate can be much higher for some other media, like audio and video. Unlike text, these other media types use a lot of space to store their data, and the need to optimize the storage and regain space was apparently very early. Engineers designed the optimized compression algorithm used by file formats designed for this specific purpose. Compression algorithms used for files can be grouped into two broad categories. Lossless compression, where the compression-decompression cycle doesn't alter the data that is recovered. It matches byte to byte with the original. For images, GIF and PNG are used in lossless compression. Lossy compression, where the cycle alters the original data in a hopefully imperceptible way for the user. Video formats on the web are lossy. The JPEG image format is also lossy. Some formats can be used for both lossless and lossy compression, like WebP, and usually lossy algorithm can be configured to compress more or less, which then, of course, leads to less or more quantity. For better performance of a website, it is ideal to compress as much as possible while keeping an acceptable level of quality. For images, an image generated by a tool could be not optimized enough for the web. It is recommended to use tools that will compress as much as possible with the required quality. There are numerous tools that are specialized for this. Lossy compression algorithms are usually more efficient than lossless ones, as compression works better on specific kind of files. It usually provides nothing to compress them at a second time. In fact, this is often counterproductive at the cost of the overhead. Algorithms usually need a dictionary that adds to the initial size, can be higher than the extra gain in compression, resulting in a larger file. Do not use the two following techniques for files in a compressed format. End-to-end compression. For compression, end-to-end compression is where the largest performance improvements of websites reside. End-to-end compression refers to a compression of the body of a message that is done by the server and will last unchanged until it reaches the client. Whatever the intermediate nodes are, they leave the body untouched. All modern browsers and servers do support it, and the only thing to negotiate is the connection algorithm to use. These algorithms are optimized for text. In the 1990s, compression technology was advancing at a rapid pace, and a number of successive algorithms have been added to the set of possible choices. Nowadays, only two are relevant: gzip, the most common one, and BR, the new challenger. To select the algorithm to use, browsers and servers use proactive content negotiation. The browser sends an accept heading encoding header with the algorithm it supports and its order of precedence. The server picks one, uses to compress the body of the response and uses the content encoding header to tell the browser that the algorithm it has chosen. As content negotiation has been used to choose a representation based on its encoding, the server must send a very header containing at least accepted encoding alongside this header in the response. That way, caches will be able to cache the different representations of the resource. As compression brings significant performance improvements, it is recommended to activate it for all files, except already compressed ones like images, audio files, and videos. Apache supports compression and uses multi-deflate. For Nginx, there is Nginx HTTP gzip module. For IIS, the HTTP compression element. Compression dictionary transport. Modern compression formats, such as Broadtail compression and Z-standard compression, can use dictionaries of frequently used data to further increase compression over just referencing those from within the file being compressed. Typically, for HTTP response, this uses a predefined static dictionary included in that format. For example, the Broadtail static dictionary is available in the source code. Compression dictionary transport enables a developer to specify a resource which can be used as a dictionary for future requests. This can either be a specific dictionary type file or an existing resource. For example, using HTTP v1 as a dictionary when downloading HTTP v2 JS. This typically improves compression and therefore load time. The HTTP vx JS example. Most of the download will consist of.你稍等会儿，我把这个读完，读完上传完我们就出去。